Welcome to this video lecture on analog electronic circuits on the topic tuned amplifiers. So let us see what is meant by tuned amplifiers. So it is an amplifier circuit which is used for radio frequency applications. Basically a transistor amplifier is used to amplify or boost up the signal without changing the information. So normal common emitter BJT amplifiers are used in audio frequencies which is up to 20 kilohertz. But when we are considering the radio frequencies, tuned amplifiers will be a useful one. So it is consists of a tank circuit or resonant circuit which is selects a particular frequency and it amplifies that particular frequency. So it is tuned to a pass or amplify a particular desired frequency or a narrow band of frequencies. It is known as a tuned circuit amplifier. So it uses a phenomenon of resonance. So in which tank circuit or resonant circuit, it's selecting a particular or relative narrow band of frequencies. The center of this frequency band is the resonant frequency of the tuned circuit. So this circuit is an example of tuned amplifier. So it consists of a common emitter circuit in which collector terminal is connected with tank circuit which is a parallel resonant circuit. So here a normal BJT common emitter amplifier circuit with tuned circuit is connected. So what is a tuned circuit? It is a parallel LC circuit. So when at a particular frequency the inductive reactance became equal to the capacitive reactance and the circuit behaves as a purely resistive circuit. So this phenomenon is called as a resonance and the corresponding frequency is called the resonant frequency. So these are the classification of tuned amplifiers. So first of all, small signal amplifiers and large signal amplifiers. So in the small signal, in normal transistor amplifier, it is used to amplify the low radio frequency signals. So the power output is low. So here we are using the class A type amplifiers. So in which there are three types. So single tuned amplifier, double tuned amplifier and a stagger tuned amplifier. So we are going to discuss these three types in this lecture. So first of all, single tuned amplifier, a simple transistor amplifier circuit. So consists of only parallel tuned circuit in the collector load. So it makes the single tune amplifier. So it consists of a one tank circuit in the collector terminal. So the values of capacitance and inductance are selected such that its resonant frequency is equal to the frequency to be amplified. So the resonant frequency is depends on the capacitance and inductance value. And the high frequency signal is given to the input of the amplifier. So at this stage, tuned circuit offers a high impedance to the signal frequency. It helps to offer the high output across the tuned circuit. For the remaining frequencies, it will be rejected by the tuned circuit. So the tuned amplifier selects and amplifies the desired frequency signal. So this is a circuit diagram of single tuned amplifier where common emitter amplifier and in the collector terminal a tuned circuit is connected where L and C tank circuit is connected and the output is taken across this circuit. And this is the frequency response of the tuned circuit amplifier. So here the parallel resonance occurs at the resonant frequency. So resonant frequency is equation is given in this. So it is 1 by 2 pi root of LC. So the resonant frequency is determined from the inductance and capacitance values. The circuit has the high quality factor. And some limitations of the single tuned amplifiers are, so tuned amplifier are required to be highly selective. So high selectivity required a tuned amplifier with a high quality factor. So it needs a high quality factor circuit gives high voltage gain. At the same time, it reduces the bandwidth because it is inversely proportional to the quality factor. So reduced bandwidth, we cannot amplify the complete band of signals. So it is in potential instability of the tuned amplifier. So this is the drawback of single tuned amplifier. So we need to overcome these drawbacks. So next we shall see the double tuned amplifiers, in which the drawbacks of single tuned can be overcome. So here the same common emitter amplifier circuit, in which double tuned circuit, that is there are two tank circuits are given at the collector terminal. So L1 C1 and L2 C2. Here the mutual coupling method is used in this double tuned amplifier. So it consists of tuned circuits. So output of the tuned circuit L1 C1 is coupled to the second tuned circuit through mutual coupling method. So remaining circuit is same as the single tuned amplifier. So here the high frequency signal to be amplified is given at the input of the amplifier. So the tuning circuit is tuned through the input signal frequency. So it offers high reactance to the input signal frequency to be passed to the output. So the large output appears across the output of the tuned circuit 1, then it is coupled to the tuned circuit 2 through the mutual induction method. So here the two tank circuits are connected through mutual coupling. So it is used for coupling various circuits of radio and television receivers. So by proper adjustment of coupling between two coils of tuned circuits, the required results, high selectivity, high voltage gain and required bandwidth may be obtained. So next type we are going to discuss is the stagger tuned amplifiers. So in which the two circuits are connected in cascade. So in the double tuned amplifier we have connected two tuned circuits. So it makes the circuit complex. To overcome that, we are connecting the two amplifier circuits in cascade with a single tuned circuit in each stage. So this is used to improve the overall frequency response of the tuned amplifiers. The stagger tuned amplifiers are usually designed so that the overall response exhibits a maximal flatness around a center frequency. So it improves the frequency response. So resonant frequencies are displaced or staggered. So this is called as a stagger tuned amplifier. So the main advantage is increased bandwidth. It also has some drawbacks such as reduced selectivity, critical tuning of many tank circuits, and it is used in RF amplifier stage in radio receivers. So some of the applications are given. So the circuits of video signal amplification in the wideband range use these amplifiers, and also wireless long distance communications with high gain amplifiers are used. And at the receiving stage, these are used as a radio frequency amplifiers. Even the devices used for communication that work on radio frequencies prefer these amplifiers. So the assessment. So here we can see the calculation of bandwidth and then reactance. So first one is, what is the bandwidth of resonant circuit with a frequency of 28 MHz and quality factor of 80. So we know the relation between quality factor and resonant frequency. So we can divide the resonant frequency by quality factor. So 28 MHz divided by 80. So it gives the bandwidth of 350 kHz. And second one, calculate the reactance of 100 picofarad capacitor at an operating frequency of 2 MHz. So the capacitive reactance is given by 1 by 2 pi Fc. So where F is the frequency given 2 MHz and C value is 100 picofarad. So we get the value of capacitive reactance as 796.2 ohms. Thank you, students.